Okay, 9.4 is derivatives of vector valued functions. So this first part of the notes here is reminding you what a vector is. So I believe you learned about vectors in geometry, maybe pre-cal? Also physics? Okay, so shouldn't be anything new, just talking about the basics of vectors. So it says vectors have a magnitude, which is length and direction. Vectors can be represented by directed line segments. So for example, if I start here and then mention my direction, that is a vector. Vectors are equal if they have the same direction and magnitude. Magnitude is designated by, and this symbol here, so it looks like two absolute value bars, V, okay, for vectors. Vectors have a horizontal and vertical component. And component form of a vector is bracket, fancy bracket, right? X comma Y. Those brackets are just for vectors. Okay. Number 1 says find the component form and magnitude of the vector that has an initial point of 1, 2 and a terminal point of 5, 4. So for component form, we know it's going to have to be in terms of x, y. So in order to look at this, we look at the x values where it stopped, and we subtract the x value where it started. So for example, x would be 5 minus 1, which is 4. And what would y be? 2. 4 minus 2, 2. Okay, so that would be the component form. We look at where it ends and subtract where it started. Okay, then it says magnitude. So remember, magnitude we represent like this. This is the symbol for magnitude. And we know magnitude is just the length of the vector. Well, if we look at the vector that we drew above, vectors are always going to be the hypotenuse of right triangles. Okay, the hypotenuse of right triangles. And we know how to find the sides of a right triangle by using what? Pythagorean theorem. So remember the a squared plus b squared equals c squared. Okay, well our hypotenuse is that c value. So in order to find that length or that magnitude, we're going to say that c is equal to the square root of a squared plus b squared. But since our terms are in terms of x and y, we're going to say this formula is the square root of x squared plus y squared. So since we already have the component form, that means we have x and y. So that means I'm plugging in 4 for x, so I have the square root of 4 squared, which is 16. Plus the square of y, so 2 squared is 4. And so I get that the magnitude or the length of that vector is the square root of 20, and that would be my answer. Okay, so again, this is just reintroducing vectors in case you forgot from previous courses. Now on to the calculus part, and that is a vectored valued function. So notice our vectors are no longer defined with v. It's now defined with r of t. Oops, I wanted the highlighter. Okay. The reason for that is instead of just having values x and y in our vector, we now have functions, and these are parametric equations. So f of t and g of t. Okay. So in order to take the derivative of a vector value function, all we need to do is take the derivative of each of the parametric equations. So the formula is r prime of t is equal to f prime of t, whatever that first function is, and g prime of t. Okay, which means if we're taking the derivative of a vectored value function, that's the same as just taking the individual derivatives of each parametric equation. Okay, then it gives us some properties of derivatives for vectored value functions. All you need to know is that these are the exact same properties of derivatives that we learned a while back. And so the first one is talking about a constant. So if we have some constant c times the function, that constant just comes out of the derivative. If we are adding or subtracting, we still just take the derivative individually. And then this one right here is two equations being multiplied. So this is the product rule. So remember, product rule was f prime g plus fg prime. Okay, of course, this is in terms of r of t and s of t, but same concept. And then lastly, this one here is the chain rule. So it says if we have a vectored value function that has another function within it, we use the chain rule and make sure we do the derivative of the outside function and multiply it by the derivative of the inside function. Okay, so the concept isn't new. We know how to do derivatives. It's just putting it in a different term, and that is vector valued functions. Any questions so far? Okay, so let's look at number 1. Number 1, it gives us r of t, and notice we have two functions in here. So in order to find the derivative, we just take the derivative of each one separately. So r prime of t is equal to, what would be the derivative of that first function? 4t plus 4, and then the derivative of the next one? 9t squared minus 4. That is our answer. Okay, so in this one, we didn't have any special rules here. It's just a polynomial. We know how to easily take the derivative of a polynomial. In number 2, it's asking us to take the derivative and then plug in another function. So that means we're going to end up using the chain rule when looking at number 2. So the first thing we should do is just take the derivative of r of t. So r prime of t is equal to, what would be the first derivative? 3t squared, and then the second one, 2. Okay. Then what we're going to do is we're going to plug in what it wants us to plug in, and that's that 2t. So r prime of 2t, and I'm just, again, plugging in 2t anywhere I see a t, which means that second part of the function where we took the derivative and got 2, it doesn't get anything. There wasn't a t there to plug in. Okay. So now that I have a function within another function, I know I'm going to use the chain rule. So what's going to happen is I'm going to end up multiplying this entire thing by what? 2. So I am going to simplify this part real quick. So 2t squared is 4t squared. 4t squared times 3 is 12t squared, comma 2. I just simplified that. And I know I'm multiplying this whole thing by 2 because of the chain rule. So I'm going to highlight right here. This is the chain rule. Okay. And what's nice about the properties of vectors is that when we multiply by 2, all we're doing is scaling the vector by 2. So that means I can take that 2 and multiply each of the functions by it, and then that would be my answer. So then I would just have 24t squared, comma 4. Okay, so any questions on 1 or 2? Okay, last one, number 3. It says the path of a particle moving along a path in the xy plane is given by the vectored value function, and then it gives it u f of t. Find the slope of the path of the particle at t is equal to 3 pi over 4. So here it's asking for the slope, and we know that slope is the same as asking for the derivative. Well, since we have two parametric equations here, instead of simply taking the derivative, because we don't want to know what the new vector would be, we actually want to know the slope in general. So that means we have to do dy dx. And so from the first notes, we know that dy dx is the same as us doing dy dt divided by dx dt, and that just means the derivative of y divided by the derivative of x. Okay, so if I was to label this, it's always x comma y in my vectors. So the first function is x and the second function is y. And so if I'm taking the derivative of y, what would be the derivative of sine? cosine, yep. And then if I'm asking for the derivative of x, and x is t squared, what's the derivative? 2t. Okay, so now that I found dy dx, the derivative, cosine t over 2t, it wants us to find when t is equal to 3 pi over 4. So I'm going to solve this when t is equal to 3 pi over 4, which means I am going to be plugging in that value for t. So I have cosine of 3 pi over 4 divided by 2 times 3 pi over 4. I know that cosine of 3 pi over 4 is negative square root of 2 over 2. And then I can just simplify the 2 and the 4 in the denominator, and I have 3 pi halves, or 3 pi over 2. And then I can simplify this because since I'm dividing two fractions, that's the same as multiplying by the reciprocal. So this is negative square root of 2 over 2 times 2 over 3 pi. The 2's cancel out, and I am left with negative square root of 2 over 3 pi, and that is my answer.